Ni hao. Hello. This is the 22nd lesson in heat transfer. In lesson 22, we will discuss internal flow convection heat transfer when the duct wall in which the fluid is flowing is held at a constant temperature. There are 3 parts to this lesson. In the first part of the lesson, we will discuss the variation of temperature in the fluid in the direction of the flow. By the end of this lesson, you should be able to provide an example of an engineering situation in which a constant tube wall temperature applies. You should also be able to sketch the surface, center line, and mean temperature of fluid flowing in a pipe subjected to a constant temperature on its wall in the direction of flow. On with the lesson.
We are now at a position where we can start, like constant flux case is interesting, but what happens if instead of a constant flux at the wall, we have a constant temperature, right? The tube wall is isothermal. So if I drew the tube again, this is some other tube now, this isn't going to apply for the absorber tube of a parabolic trough concentrator, it's something else. But now there's something that's holding the temperature of the tube wall constant. What's going to happen in that case? So just before, I'm going to ask you to sketch, right, how temperature is going to change, but where would you see something like this, like practically? Where might it be that the tube wall is isothermal? Like under what situations would you see an isothermal tube wall? Yeah, Kate?
Like a geothermal system, when you put it deep enough on the ground, I consider that.
Okay, so yeah, so if the ground were isothermal, and it is isothermal if you go deep enough down, basically, in local regions, yeah, that might be the case. Sure, so I like that. So geothermal heating systems. The one that I think of first are phase changes. Phase changes hold the temperature fixed, right? So if we had, say, water evaporating on the outside of this tube or water condensing on the outside of this tube, we're going to have the phase change, like whatever the temperature associated with that saturated mixture is, right, in the vapor dome, that's going to be the temperature everywhere in the phase change process. It's not going to change. So those are some great, yeah, these are great examples. And perhaps too, right, pipes in the wall of our house, if the walls, if the house is isothermal. Okay, good. Now, I want you to take some time and I want you to sketch how you think the surface temperature is changing, although that one's pretty easy, right? The surface temperature is a constant. So that, again, sketch the mean temperature. How do you think the mean temperature is going to change? And sketch the temperature at the center line. What do you think is going to happen? Okay, I'm just asking you to make a sketch. You don't know the answer yet, just make an educated guess, okay? I'll give you a couple of minutes.
Now, what I would like you to do is pause the video and write down an answer to the question.
So lots of really good thinking out there, and the vast majority of you had TS is just a constant, right? And what I saw for many of you for TM was, if this is TMI, was something that looked like that. So there was some kind of an exponential increase, right? Or an exponential decrease in the temperature difference that's driving the heat transfer. And then I saw for the center line temperature, right, a flat line again, because it's still heating from the, I guess if you're thinking in terms of heating, it's still heating from the outside in. So there is a developing length, right? And so the center line is not going to feel the effects of the heating for a while, and then it starts to increase. I saw it's like, exponentially too. That is a very good guess, okay? So this is exactly how it's going to happen in this isothermal tube wall case. Looks totally different than the constant flux case, right? Totally different. Right? There is no continued, you're going to see. If you guess the linear change, that's okay. Okay, it was just a guess, right? But we're going to go convince ourselves that it is going to be exponential here in a second. But it looks different, very different, yeah. It's not linear like it was for the constant flux case.